All right, further graphs. Now, graphs of functions with asymptotes can be difficult to sketch. This is extension now, extension 1. It is important to find the limits as the function approaches asymptotes. So, but here is a special limit that you need to know. So can we just write this down? A special limit is the limit as x approaches infinity of the function 1 on x equals 0. We know that one because what's that graph of? Y equals 1 on x. Isn't that a hyperbola? So a special limit is the limit as x approaches infinity of 1 on x equals 0. So this is, you need to know this result. The limit as x approaches infinity of the function 1 on x equals 0. So notice in the last exercise we were doing the limit as x approaches 2, the limit as x approaches 0. This one's different. This is the limit of the function as x gets large. Let's just have a quick sketch of this function. Can we see why the answer's y it's 0? This is the function y equals 1 on x. Okay? And we can see as x approaches infinity, doesn't y approach what? 0. You tell me if it's from above or below. Above. As x approaches infinity, y approaches 0 from above. As x approaches negative infinity, you tell me what y approaches. 0 from below. That's what that little plus and minus means. So this approaches 0 from above. Yeah, we know it's approaching 0, but it's coming from the positive y values. This is approaching 0 from below. Okay? So that's that function there. But while I'm here as well, I'm just going to put as x approaches 0 from above and as x approaches 0 from below, what does y approach? Because this is going to help us with our sketching. So as x approaches 0, but from the positive end, what does y approach? Positive infinity. As x approaches 0 here, from the positive values, y is getting very large and positive. So positive infinity. You okay with that? And as x approaches 0 from the negative values, y approaches negative infinity. Okay? So you already knew this. It's just that this result was never formalized for you. Okay? Right? We want to be able to use the result. We want to be able to substitute into the result limit as x approaches in. We want to be able to substitute into things of the form 1 on x or 1 on x squared. At the moment, we can't see that. So what we do, to do these sorts of questions, there is a rule. We need to divide by the highest power. Always divide by the highest power in the denominator. So we're going to divide through by the highest power in the denominator. So we get limit as x approaches infinity. So each of these terms needs to be divided through by x squared. Are we okay with this? So what we do, we can't substitute. We want to use the result, limit as x approaches infinity of 1 on x equals 0. I can't use that result with what I've got. So limit as x approaches infinity for 5x over x squared plus 1. I need to divide each term by the highest power in the denominator. So I'm dividing each term by x squared. Are we okay with that? So it's the limit as x approaches infinity of all that, which is the limit as x approaches infinity of, now, what's 5x over x squared, isn't it? 5 on x over x squared on x squared is 1, and 1 on x squared is 1 on x squared. Now I can substitute. Because I know that the limit as x approaches infinity of 1 on x is 0. So, isn't 5 on x the same as 5 times 1 on x? Do you get that or not? So that is the limit as x approaches infinity of 5 on x is 5 times 1 on x. That will be 0. Look, if you substituted a really large value of x here, it's going to approach 0. 5 over 1,000, 0.005. X is, do you get it? X is 100, 0.05 is what you would get there. So this approaches 0. Limit as x approaches infinity of 1 on x is 0. So same 2 on x will be 0. 3 on x will be 0 because 5 on x will be 0 because that's 5 times 1 on x. So it'll be 5 times 0 is 0. 1 doesn't, there's no x's to substitute. 1 on x squared is 1 on x times 1 on x. So it's 0 times 0 is 0. So in other words, this function, this is allowed. I'm allowed to divide 0 by 1. Do you get it? But I can't do 1 divided by 0. So what do I get? What's 0 divided by 1? 0. In other words, if I sketch this function, when x gets really big, my curve is going to approach 0. That's what it's telling me. What is the limit as x approaches infinity for this function? Now what you could do, we could test this. Let's just substitute into the original function x is 10 or 100. Let's go. X is 100. Now, you don't do the whole thing with x is 100. Wouldn't that be 500 divided by 10,001? 500 divided by 10,001. Can someone do it, please? So I want 500, because that's 5 times 100, divided by 100 squared is 10,000 plus 1. So 500 divided by 10,001, and what do you get? 0.0 what? Sorry? 0.049, etc. Do you think that this is approaching 0? Okay. And from above as well. Okay, so it's approaching 0. Do you see? So you can do it by, yes, by substituting, but we're going to do it this way, using limits. So the next one. The limit as x approaches infinity of x squared over 4x cubed plus 27x minus 9. What do I divide through by? The highest power of what? Yes, but you don't have to divide by 4x cubed, just x cubed. Divide by the highest power in the denominator. Now, the reason we need to divide by the highest power in the denominator, not the numerator, is if we divide by the highest power in the numerator, we're going to end up with zeros on the denominator. And we don't want zeros on the denominator, like only zeros. All right, so I'm going to divide through by x cubed over 4x cubed over x cubed plus 27x over x cubed minus 9 over x cubed. Are we okay with this? Equals the limit as x approaches infinity of x squared on x cubed is 1 on x over 4 plus 27 over what? 27 over x squared minus 9 over x cubed. Now, anytime you see anything of the form 1 on x squared, 1 on x cubed, because 1 on x squared is 1 on x times 1 on x. Don't worry if there's 9s and 27s on top. All right, you will get 0 for each of those for anything over x. So now I can substitute. So once I'm done, and they're all in that form of something on x squared, something on x cubed, each of those, limit as x approaches infinity of 1 on x is 0. Well, you can't substitute into 4. Plus, what will the others be? 0 minus 0. So that's 0 over 4, which I am allowed to do. And what's my answer? 0. So that particular function, if I sketched it for very big values of x, my curve approaches 0. Okay? I think this one would still probably be from above because that's positive. As x approaches big positive values, that would be very positive, big positive number minus little 9. That's approaching 0 from above if you were to substitute some values in, big values. 1j, limit as x approaches infinity of 3 root x over root x minus 1. What's the highest power of x? What's the highest power of x? Root x, isn't it? On the denominator. So dividing through by root x, which is what do you get? Do you get 3 over, this is no good. Oh, I forgot to divide this by root x. Thank you. So it's the limit as x approaches infinity of, now you could just substitute, you know your root x when you substitute a big value of x, like x is 100. So I divided each term by root x. You get 3 over 1 minus, like when x is 100, for example, you get 1 over 10, which is 0.1. It's going to be the same. When the limit as x approaches infinity of 1 on x is 0, same with 1 on root x. What about when x is 10,000? You get 1 minus 1 over 10,000, 1 minus 1 over 100, 1 minus 0.01. Oh, you get 0. That approaches 0. Okay with that? Because it's 1 divided by a big value. So limit as x approaches infinity of 1 on x is 0. Limit, so what have we got? I'm just going to put them all over here. The limit as x approaches infinity of 1 on x is 0. The limit as x approaches infinity of 1 on x squared, etc. is 0. Are we okay with those? Because that's just 1 on x times 1 on x. The limit as x approaches infinity of 1 on x cubed would also be 0. 1 on root x would also be 0. Because as you put in a big value of x, you're going to get 1 divided by a big number. Does that make sense? So, what's the answer to this one? Oh, this one's a bit different. What do we get? 3 over 1, which is 3. That one's not 0. I want to sketch that one. Want me to sketch it? So if I sketched y equals 3 root x over the square root of x minus 1, I would get 3. Y equals 3 root x over the square root of x minus 1. Can you see I'm getting an asymptote? And that's 2 there. It's going to approach 3. It's getting there, but it's approaching 3. Can you see? That's 2, that's 4. It's approaching 3. It will approach 3. Can you see? All right, it's getting there. We're already up to 168. Well, there's 200, and it's approaching 3. 3's down here. All right? No, it'll never meet it. Okay? I show that x squared plus 3 over x squared equals that. I'm going to start with x squared plus x plus 3 over x squared. That's my left-hand side. Doesn't that mean just to divide each term by x squared? That's what that means. That's all. Which is x squared on x squared is 1. X on x squared is 1 on x. And 3 on x squared is just 3 on x squared. Okay? And now for part B, we just do the limit as x approaches positive infinity. You know how to do that? Divide each term by. So limit as x approaches infinity of that will be dividing each term by x squared. So it will just be, I'll just come over here, equals the limit as x approaches infinity of 1 plus 1 on x plus 3 on x squared over 1. Remember, we're dividing by the highest power of x squared. Substituting in x is infinity, you get 1 plus 0 over 1, which is 1. Now, all right, you know, if you look at the original function, all right, part A and B. Yeah. If we look at the original function, you know how we rearranged it? Isn't this just a hyperbola and another hyperbola shifted up 1 unit? That's what that function is. This is a hyperbola plus another one shifted up 1 unit. That's why the limit, the asymptote will be, if I didn't have the 1 there, the asymptote here is 0. Y is 0, but this plus 1 means the asymptote's at positive 1. That's what this is telling me. We'll continue with this next lesson. Okay, so we've looked at the limit as x approaches infinity for the same function that we were looking up there, and we got the limit as x approaches positive infinity as 1. So in other words, the graph function of x equals x squared plus x plus 3 over x squared, as we get very large values for x, the function will approach 1. Will approach a y value of 1. Now we're also going to look at the limit as x approaches negative infinity, just doing it the same way. So that's the limit as x approaches negative infinity of x squared on x squared plus x on x squared plus 3 on x squared over x squared on x squared, which is the limit as x approaches negative infinity of 1 plus 1 on x plus 3 over x squared over 1. Now, as x gets really large and negative, the value of 1 won't change on the numerator or the denominator. But 1 on x, for example, 1 over negative 100 would be negative 0.01. 1 over negative 1,000 would be negative 0.0001. So that approaches 0, but from below. And 3 over x squared would approach 0 from above. So if x was 100, it would be 3 over 10,000, which is 0.00003, I think, or could be wrong there with one of the zeros, but it approaches 0. So the limit, again, so as x approaches infinity limit as x approaches infinity for 1 on x is 0, but limit as x approaches negative infinity for 1 on x is also 0. Okay, and if x was negative here and you square it, it's going to be the same as limit as x approaches positive infinity, because any x value squared would be positive. So this graph approaches 1 for large negative values as well. Okay, now let's look at those two. So so what we've done with this function, if we have y equals this function, we can show that it is a hyperbola and another hyperbola sort of added together and shifted up 1 unit. So if I was to sketch 1 on x, I know that that looks like this. 3 on x squared would look very similar. If you add them together, it would look very similar. But then the whole thing is shifted up 1 unit, okay? So it would sort of look like this in this quadrant anyway. The other quadrant down here might be a bit different, okay? So I'm just drawing that section of it. But we can see that the whole graph has been shifted up 1 unit, that there is an asymptote at y equals 1, which is why so if we just look at this graph and I wanted to sketch it, I could. I'm just going to go to Desmos and show you. Desmos to sketch this graph, and here it is. So this is the graph of y equals 1 plus 1 on x plus 3 over x squared, or I could have put it all in the original form as well. And I can see here is y equals 1, that the curves are approaching y equals 1. Now this on the left hand side approaches y equals 1, but it's coming from below. Okay, it is approaching y equals 1 because this is 1, but it's approaching from below, and this curve is approaching it from above. Okay, so we can see the limit. So we can see here that y is 1 and this curve is approaching 1. Okay, so these are both approaching 1. I can also put the function in its original format, which is y equals, again, x squared plus x plus 3 all divided by x squared. Same graph, okay? Same as what I had before. So I've put the graph in this format, okay? And it also has an asymptote of 1 as well. This one's a bit different. It comes below 1 and then comes back and approaches the line. We'll be looking at functions like that later. And so after looking at Desmos, the function actually looks like this, but it did go a bit below the line there and then it comes back and approaches there. Okay, don't worry about not being able to do that yet. We'll look at sketching things like this a little bit later on. Okay, but this is why we're getting limit as x approaches positive infinity is 1, and also limit as x approaches negative infinity is also 1 down here. Question 4b. Now, if we look at this particular question, remember we're supposed to divide by the highest power of x in the denominator, but let's say we forgot about that rule and we divide through by the highest power of x in the numerator. You'll see what we get. So let's say we forgot that we divide by the highest power of x in the denominator and we divide by the highest power of x that we can just see overall. This is what would happen. So we'd divide each of these by x cubed and we'd get the limit as x approaches infinity of 5x cubed on x cubed is 5 over 4x on x cubed is 4 and x squared plus 3 over x cubed. And now when we substitute into this, we get 5 over 0 plus 0, which is undefined, which we can't do, which is why we do not divide by the highest power overall. So we can't do this. So we do it, we just divide by the highest power of x in the denominator. So let's look at the question again. And we're going to divide by highest power of x in the denominator. So you will know what to do. Let's say you divide it by x cubed and you get 5 divided by 0 plus 0, and you know that you can't do that. Then hopefully that will trigger your memory that you divide by the highest power of x. Sorry, that's a cubed. You divide by the highest power of x in the denominator, not the numerator. So we divide each term by x. Okay, so 4x over x plus 3 over x. And that is the limit as x approaches infinity. 5x cubed on x is 5x squared over 4x over x is 4 plus 3 over x is 3 over x. And now we substitute. Now, as x gets really big, 5x squared, its value is going to be 5x squared. Let's say if x was 10, I would get 5 times 10 squared is 500. If x was 100, I'd get 5 times 100 squared, which is 50,000. So the limit as x approaches infinity for this will be whatever 5x squared is, it will be. Okay, so we don't put infinity. So it's 5x squared over, again, substituting x as limit as x approaches infinity. The 4 doesn't change, and 3 over x divided by x becomes 0. So we have 5x squared over 4. And that is what this curve approaches as x approaches infinity. That curve will approach this function, 5x squared over 4. Okay?